This one's asking, what is the definition of mole ratio? So that being said, okay, as we actually look at what it says in the answer, mole ratio is a ratio between the amount of moles in any chemical reaction. So if I were to just start with that, for example, I had, let's try sodium sulfate. So I had NaS, no, Na, let's try sodium phosphate, Na3PO4 plus CaSO4. Okay, like that turns into, and it's just theoretical, but it turns into now Na2SO4 plus Ca, so calcium 3PO4 2, because okay, that's just going to be a theoretical thing. Now we want to make sure we balance out the equation. So we have 3 sulfates here because the 3 calciums there. Because of that, we're going to have now, just to make sure I'm doing this correctly, we're now going to have for SO4, we have 1 SO4, we're going to have 3 SO4 there. Okay, so 3 Na2SO4 will be 2. Because there's 2, this perfectly matches actually how much of the phosphate we already have there. So we should have 6 Na. Okay, so 6 Na cancels out. 2 PO4 and 2 PO4 cancel out. We have 3 calciums, and here we also have 3 calciums. Okay, cancel out. We had SO4 in the last one, and this one had 3 SO4, and this one had also 3 SO4. So perfect, it's completely balanced. And now to find out the mole ratio, you look at the specifically the coefficients. Okay, so okay. What this means is that for this, in this question, we need a 2 to 3 mole ratio for the reactants. What does that mean is that if I were to want this to react to completion and have nothing left over, we have to theoretically make sure that as close as we can stick to the these, I guess, mole ratios, because that way, if you always have a 2 to 3 ratio, theoretically, every sodium phosphate should be used up by every calcium sulfate. And you can even see here on the product side, okay, the mole ratio is pretty much saying 3 to 1. Because when you don't have coefficients, you usually just assume that's 1. So that means if you put it all together, really, if you go from products to reactants, is that you need only 2 moles of sodium phosphate and 3 moles of calcium sulfate to be able to make 3 moles of sodium sulfate and 1 mole of calcium phosphate. So it's kind of just what it's saying right here. It's just the definition of the mole ratio. It just helps you kind of establish relationships. So especially when you're dealing with like limiting and excess reagents, you know which one is the limiting and which one is the excess based on the mole ratio and how others compare to that mole ratio. Exactly. It's very helpful to use as a conversion factor when dealing with products and reactants, or when solving problems using stoichiometry. And mole ratio can be determined by examining the coefficients in a balanced chemical equation. So exactly, when they show the water, the 2 hydrogens and the 1 oxygen, the mole ratio of O2 to H2O is 1:2, because they did the products to the reactants, specifically oxygen as a product. You can truly pick anything to establish a mole ratio, because it also helps you convert. For example, as I said, I started out with 0.2 moles of CaSO4. Alright, and so 0.2. I want to know, it's not 0.2, 0.3. I want to know how much of Ca3PO4, so calcium phosphate, was produced. We have to divide first by our coefficient of what we started with, so that's 3, and then times the coefficient of what we ended with, that's 1. So in reality, the amount of moles produced based on having 3.3 moles of the CaSO4 is going to just be 0.1 moles of that. Okay, that is how that works. And you notice that 0.1 and 0.3 are indeed forming that 3113 fraction that they should have as well. So that is going to be our mole ratio. This is correct. And I'm going to say it again, this is quite crucial, especially when dealing with excess and limiting reagents. It's important to be able to identify which one is your excess and which one is your limiting. And that can usually be done simply by your mole ratio. If the mole ratio, for example, it says 2,3 for the products, reactants. If it was 2,3 and then all of a sudden I realized I had like 2.05 moles and 3.92 moles of the reactants, then this is going to be your excess. This is going way above your limiting of or way above a 3. So you can see here in this case that the excess is usually marked with how much, if they do surpass or go behind the ratio. Okay. So now let's see here.